Hello students and good morning. So now I'm doing class for class 10. The topic is real life problems related to different solid objects. So in the last online class also we were doing the same topic, but in that case we did long type of questions and answers. Okay, we did long type of problems in that online class. So today we'll do very short answer type question which carries 1 mark each. So this is a multiple choice question. So let us work out exercise 19, page number 266 from the book Ganit Prakash for class 10 by West Bengal Board of Secondary Education. So let's start our work now. So this is question number 17, VSA, that means very short answer type question. And this is a multiple choice question, MCQ, that is you have to choose the correct option in this case. So question number 1 is, a solid sphere of R unit radius is melted and from it a solid right circular cone is made, and the base radius of the cone is A, B, C and D. Which is the correct option? You have to check it. Okay, so in the question the condition is given that the height of the cone is equal to the radius of the sphere. The height of the cone is equal to the radius of the sphere. Okay, so now the question is, you have to understand the question. So there is a solid sphere of radius R unit, it is melted and a solid right circular cone is made from it. Now you have to find out the radius of the cone, that is the base radius of the cone is, which is the correct option here. It is whether it is A, 2R unit, B, 3R unit, C, R unit or D, 4R unit. Again the condition is given that the height of the cone is equal to the radius of the sphere. So I think you have understood the question. So let's do this work now. So what is the radius of the sphere? Now this is the solution. So radius of the sphere. So radius of the sphere is equal to, this is R unit. Now this sphere is melted. This sphere is melted and a right circular cone is made. That means you have to find out the volume of the sphere. Okay, so when the sphere is melted and a right circular cone is made, so you have to, in this case you have to find out the volume of the sphere. Okay, so therefore volume of the sphere, so volume of the sphere, what is the formula? Volume of the sphere is equal to, this is 4/3 pi r cube. That is cubic unit. This is cubic unit. Is that clear now? So now this sphere is melted and a right circular cone is made whose height is equal to the radius of the sphere. So now in this case you have to find out the base radius of the cone. Let the base radius of the cone be R unit. Let the base radius of the cone be R unit. So you know that what type of figure is the cone, you know that, isn't it? Now in this case, what is the height of the cone? Therefore height of the cone by question is equal to the radius of the sphere. That means height of the cone is equal to, that is, what is the radius of the sphere? It is R unit. Okay, so now let us find out the volume of the cone. Because a sphere is melted and a right circular cone is made, that means in this case also you have to find out the volume of the right circular cone. So what is the formula? Let us write down the formula. Volume of the solid cone. What is the formula? It is 1/3 pi r square h. It is 1/3 pi r square h. Okay, so which is equal to 1/3 pi. In this case, what is the radius of the cone? What is the base radius of the cone? It is capital R. So it is capital R square into what is the height of the cone? It is equal to the radius of the sphere, that is small r. Is that understood now? So let us use the concept here, that is volume of the cone is equal to volume of the sphere, because here the sphere is melted and a right circular cone is made. That means the volume of the sphere is equal to the volume of the cone. So therefore, in this case, volume of the cone, because sphere is melted, since sphere is melted and from here a cone is made, that means from here we can understand that volume of the sphere is equal to volume of the cone. Volume of the sphere is equal to volume of the cone is equal to volume of the cone. Or what is the volume of the sphere in this case? It is 4/3 pi r cube. It is 4/3 pi r cube is equal to, what is the volume of the cone? It is 1/3 pi. It is 1/3 pi capital R square into small r. So in this case, you have to find out the radius of the base of the cone. That is, you have to find out the value for capital R. So here this 3 gets cancels, and here pi gets cancels, or what do we get? It is 4r cube is equal to capital R square into small r. Again this small r and this r cube will be cancelled, which is r square. So or it is 4 small r square is equal to capital R square. Now in this case, you have to find out the value for capital R. So what is 4r square in terms of whole square? You have to write 4r square in terms of whole square. That is, this is your 2r whole square, which is equal to, this is capital R square. Now if the powers are equal, bases must be equal. That is, capital R is equal to 2r. That is, capital R is equal to 2r. So actually what was capital R? Base radius of the cone is equal to capital R unit, so which is equal to 2r unit. Therefore base radius of the cone is equal to 2r unit. So this is the answer. So which is the correct answer in this case? That is, A is the correct answer. That is, A option is correct. Yeah, 2r unit is correct. So here 2r unit is correct. So I think you have understood it. So you can copy it. Now we'll do the next question. So now we'll do the next question, that is 17A number 2. This is also multiple choice question type. So question number 2 is, by melting a solid right circular cone, a solid right circular cylinder of same radius is made, whose height is 5 centimeter. So the height of the cone is, which is the correct option? You have to check it, whether it is 10 centimeter, B 15 centimeter, C 18 centimeter, or D 24 centimeter. So in this case also you have to understand a question. So you have to understand this question, right? So in this case, a solid right circular cone is given. Okay, that solid right circular cone is melted, and from there a solid right circular cylinder is made, whose radius is same as radius of the base of the cone. And what is the height of the cylinder? The height of the cylinder is 5 centimeter. So you have to find out the height of the cone. So you have to choose the correct option, whether it is A, B, C or D. You have to choose the correct option. So I think you have understood the question. So let's do this question now. So this is the solution. So now in this case, you have to find out the height of the cone. Let h be the height of the cone. Let h be the height of the cone. Let h be the height of the cone. Okay. Now in this case, in the question it is given that the radius, that is the radius of both the cone and the cylinder are same. the radius of the base of the cylinder is equal to the radius of the base of the cone. So let the base radius of the cone be r. Let the base radius of the cone be r. Okay, so let us find out the volume of the cone. Therefore volume of the cone is equal to, it is pi r square h, 1/3, sorry, this is the volume of the cone, so it is 1/3 pi r square h. So what is the formula for volume of the cone? It is 1/3 pi r square h. So this is the volume of the cone. Now this cone is melted and a solid right circular cylinder is made, whose radius is same as radius of the base of the cone and whose height is 5 centimeter. So now height of the cylinder is equal to, how much is it given? It is 5 centimeter. And what is the radius of the cylinder? It is r. Radius of the cylinder is equal to r. What is the radius of the cylinder? It is r. So what is the volume of the cylinder now? Therefore volume of the cylinder, now we have to find out the volume of the cylinder. So what is the formula? So what is the formula for volume of the cylinder? It is pi r square h. Volume of the cone is 1/3 pi r square h. Volume of the cylinder is pi r square h. So pi remains as it is. Here r is r square into 5. So I think you have understood it. So now in this case, this is your cubic centimeter. This is also cubic centimeter. Now in this case, a cone is melted and a right circular cylinder is made. That means, so from this we can understand that the volume of the cone is equal to volume of the cylinder. So let us write here, therefore volume of the cone is equal to what? Volume of the cylinder is equal to volume of the cylinder or what is the volume of the cone in this case? Volume of the cone is 1/3 pi r square h. It is 1/3 pi r square h is equal to, what is the volume of the cylinder? It is pi r square 5, pi r square into 5. So here you can cancel this, pi gets cancels, r square will be cancelled. So now if you cross multiply it, so it will be h is equal to 3 5s are 15. So what is h out here? Here height of the cone, h is the height of the cone. So what is the height of the cone? It is 15 centimeter. So therefore height of the cone is equal to 15 centimeter. So this is the final answer. Okay, so which is the correct option in this case? B, that is 15 centimeter is correct. That is 15 centimeter. B 15 centimeter is correct. So this is the correct answer. So you can copy it. Now we'll do the next question. So now we'll do the next question, that is 17A number 3. This is also multiple choice question type. So question number 3 is, the length of the radius of a right circular cylinder is r unit. That is, the length of the radius of a right circular cylinder is r unit and its height is 2r unit. That it is double of radius. Height is the double of radius, that is 2r unit. So the length of the diameter of the largest sphere that can be kept in the cylinder is A. Is it R unit? B. Is it 2R unit? C. Is it R by 2 unit? Is it D 4R unit? So let us try to understand this question now. So there is a cylinder whose base radius is R unit and its height is double of the radius of the cylinder. That is, the height is 2R unit. So in this case, the length of the diameter of the largest sphere, the length of the diameter of the largest sphere that can be kept into that cylinder will be, is it R unit? Is it 2R unit? Is it R by 2 unit? Is it 4R unit? तो यहाँ क्वेश्चन में के दिएको छ भन्दाखेरि there is a cylinder, त्यो सिलिन्डर को बेस रेडियस कति दिएको छ R unit अनि त्यसको हाइट कति दिएको छ 2R unit. त तिमीले यहाँ के निकाल्नु पर्छ? You have to find out the length. You have to find out the length of the radius of the largest sphere, not the radius, but it is the diameter. You have to find out the length of the diameter of the largest sphere that can be kept inside that cylinder. So the options are given here. Whether it is R unit, is it 2R unit, is it R by 2 unit, or D 4R unit. So let us do this problem now. So let us draw the figure here. So there is a cylinder here. So this is a cylinder, right? So you know that this is a cylinder. So its height is 2R unit. And what is the length of the radius of the right circular cylinder? It is R unit. This is R unit. This is 2R unit. And this is R unit. So now we have to find out the length of the diameter of the largest sphere that can be kept into this, that can be kept inside this cylinder. Okay. So a largest sphere, suppose this is the largest sphere that can be kept inside the cylinder, right? So this is the largest sphere that can be kept inside this cylinder. Okay. So now what will be the radius of this sphere now? So the radius of this sphere will be equal to the radius of the cylinder, isn't it? So this is also R unit. So only the sphere that is of R radius can be kept into this cylinder. That is the largest sphere. That is, what is the radius of this largest sphere? The radius of this largest sphere will be equal to R unit. Only this largest sphere of R unit radius can be put into that cylinder. Okay. So what is the radius of the largest sphere that can be put into the cylinder? It is R unit. So what is the diameter of that sphere? It is 2R unit. Okay. So here you can write, so therefore the largest sphere of radius R unit can be kept into that cylinder whose radius is R unit. Okay. The largest sphere of radius R unit can be kept into that cylinder whose radius is R unit. That means what is the diameter? So you have to find out the diameter of the largest sphere. Therefore diameter of the largest sphere that can be kept in that cylinder is equal to, so radius is R unit. What is its diameter? It is 2R unit. So this is the answer. So what is the diameter of the largest sphere that can be kept in that cylinder? So it is 2R unit. So which is the correct option here? It is B. So B, 2R unit is correct. So from the figure we can understand that the largest sphere of the largest sphere of R unit can be kept in that cylinder, whose radius is equal to the radius of the base of the cylinder. Is that clear? So what is the diameter of the largest sphere that can be kept in that cylinder? It is of 2R unit. So which is the correct option? B, 2R unit is correct. Is that clear? So we can copy it. Now we'll do the next question. So now we'll do the next question, that is question number 4. That is question number 17, number A, number 4. This is also multiple choice question type. The question is the volume of the largest solid cone. The volume of the largest solid cone that can be cut out from a solid hemisphere of R unit radius is it number A, 4 pi R cube unit cube? Is it number B, 3 pi R cube unit cube? And number C, pi R cube by 4 unit cube? Or number D, pi R cube by 3 unit cube? So there is a solid hemisphere. There is a solid hemisphere whose radius is R unit, and from there a largest solid cone is made. And from there a solid largest cone is made. So you have to find out the volume of that largest solid cone that can be cut out from a solid hemisphere of radius R unit. So you have to find out the volume of that largest solid cone. Whether it is number A, 4 pi R cube unit cube, number B, 3 pi R cube unit cube, number C, pi R cube by 4 unit cube, or number D, pi R cube by 3 unit cube. एउटा के दिएको छ भन्दाखेरि there is a solid hemisphere. Hemisphere भनेको आधी sphere. Hemisphere भनेको आधी solid hemisphere is given whose radius is R unit. And from there a largest solid cone is cut out from that hemisphere. And you have to find out the volume of that largest solid cone. Whether it is A, B, C or D, you have to choose the correct option. So let us draw the figure now. Let us draw the hemisphere first. Suppose this is the hemisphere, right? Suppose this is the hemisphere. Suppose this is the hemisphere. Is that clear? Now, what is the radius of this hemisphere? The radius of the hemisphere is R unit. The radius of the hemisphere is what? R unit. What is the height of this hemisphere? That is also R unit. Is that clear? So in this case, from this figure, it is understood that the radius of the hemisphere is R unit, and also the height of the hemisphere is also R unit. And from here, the largest solid cone is cut out. Okay, now you have to draw the largest solid cone from this hemisphere. Okay, so now this base will be the base of the cone now. So this is the solid cone. So this is the solid cone. So from the figure it is understood that what is the radius of the base of the cone? It is R unit. And what is the height of the cone? That is also R unit. So it is understood, right? So here you can write, therefore radius of the hemisphere. So radius of the hemisphere is equal to R unit. And from here the largest solid cone is cut out. Okay, so it is understood that radius of the base of the cone, radius of the base of the cone is r unit. And what is the height of the cone? Height of the cone is also r unit. From the figure it is understood. Okay, so what is the height of the cone? Height of the cone is also r unit. Is that understood now? So now we can easily find out the volume of the largest solid cone. Therefore, volume of the largest solid cone, volume of the largest solid cone, volume of the largest solid cone is equal to, what is the formula? 1/3 pi r square h. Okay, so it is 1/3, this is pi. What is r? R is the radius of the base of the cone, that is also r. That is r square into what is the height of the cone, that is also r. So which is equal to, so it is pi r cube by 3 unit cube. Okay, so which is the correct option now? It is number D. D is the correct option. So here you can write D pi r cube upon 3 unit cube is correct. So this is the final answer. So I think you have understood it. So you can copy it. Now we'll do the next question. So now we'll do the next question, that is question number 5. This is 17A multiple choice question type, that is question number 5. The question number 5 is that if from a solid cube with edge of x unit length, the largest solid sphere is cut out. The largest solid sphere is cut out, then the length of the diameter of the sphere is, whether it is A, x unit, number B, 2x unit, number C, x by 2 unit, or number D, 4x unit. So in the question it is given that there is a cube whose each of length of the edge is x unit. Okay, there is a solid cube. There is a solid cube whose length of each edge is x unit. And from there, the largest solid sphere is cut out. From there, a largest solid sphere is cut out. Okay, then you have to find out the length of the diameter of that sphere. So what will be the length of the diameter of that sphere? The options are given out here, that is A, x unit, B, 2x unit, C, x by 2 unit, D, 4x unit. You have to choose the correct option. Okay, तो यहाँ के दिएको छ भन्दाखेरि सलिड क्यूब दिएको छ जसको प्रत्येक एज को लेंथ चाहिँ कति दिएको छ x unit, that is length is equal to breadth is equal to height. You know that a rectangular parallelepiped or a cuboid will be a cube if length is equal to breadth is equal to height. That is, each of these length, breadth and height is known as the edge in case of cube. So here the length of each edge of the cube is given as x unit. Okay, now from there the largest solid sphere is cut out. So you have to find out the diameter of that largest sphere. You have to find out the diameter of that largest sphere that has been cut out from the cube of each of length of edge is x unit. Okay, is that clear? तो यहाँ क्यूब को लेंथ अफ इच एज अफ द क्यूब कति रहेछ x युनिट. यहाँबाट चाहिँ एउटा largest solid sphere is cut out, so you have to find out the diameter of that largest sphere. Okay, so whether it is A, B, C or D, you have to choose the correct option. Okay, so let us draw the figure. Let us draw the cube now first. A cube is made, right? So this is a cube. So this is a cube, right, whose length of each edge is x unit. So this is the cube. Okay, so length of each edge is x unit. This is x, this is also x, this is also x unit, this is also x unit. Okay, so from this cube the largest solid sphere is cut out. So here is the largest solid sphere. So a largest solid sphere is cut out from this solid cube. Okay, from this solid cube a largest sphere is cut out. So what will be the diameter of this sphere? Okay, so this is x unit, so this is the center of the sphere. So this length, that is diameter of the sphere, is equal to length of each edge of the cube, that is also x unit, that is also x unit. Okay, so from this figure we know that the diameter of the sphere is also x unit. Okay, because from this cube the largest solid sphere is cut out. So what will be the diameter of this largest solid sphere? It will be equal to the length of each edge of the cube, which is equal to x unit. So directly you can write down that here. Therefore from the figure it is known that diameter of the solid sphere, diameter of the largest, let us write here, largest, diameter of the largest solid sphere that has been cut out, that has been cut out from the solid cube, that has been cut out from the solid cube of each of a solid cube of length of each edge, solid cube of length of each edge x unit is equal to, what is it? Is also x unit. So this is the answer. That is, the diameter of the largest solid sphere that has been cut out from the solid cube of length of each edge x unit is equal to what? X unit. So what is the diameter of the solid sphere? That is also x unit. So in this case you have to find out the length of the diameter of the sphere, that is x unit. So which is the correct option? Number A, x unit is correct. So number A, x unit is correct. So this is the answer. So I think you have understood it. So you can copy it. Now we'll do the next question. So now we will do another type of question, that is question number 17B. This is also very short answer type question, but it is of different type. So let us write whether the following statements are true or false. So whether the given statement is true or false, you have to write it. Okay, so the question is, number one, if two solid hemispheres of the same type whose base radii are r unit each, and if they are connected along the base, then the total surface area of the connected solid is 6 pi r square unit. So whether the statement is correct or wrong, you have to check it. So try to understand. So there is two solid hemispheres of the same base radii. There are two solid hemispheres of the same base radii. Now they are connected along the base. So a solid sphere is formed. So you have to check whether the total surface area of the connected solid is 6 pi r square unit or not. You have to check it. Okay, so there are two solid hemispheres, right, of the same type and having the same base radii. This is one of the solid hemisphere. Suppose its radius is r unit. Okay, and there is another type of, and there is same type of hemisphere whose base radii are same. Whose base radii are what? It is same, right? So this is also a hemisphere whose base radius is r unit. Whose base radius is r unit, and they are of same type. Now if they are connected with the help of base, now they are connected. These two solid hemispheres are connected along with their bases. Okay, now suppose this solid is connected along with the base out here. Okay, so this is a solid hemisphere. This is a solid sphere, not hemisphere, but now this is a full sphere, isn't it? This is a solid sphere. Now, is the total surface area of the connected solid is 6 pi r square unit? No, it will be 4 pi r square. What will be the total surface area of this sphere? It will be 4 pi r square unit. That is the total surface area, means त्यो वरिपरिको एरिया चाहिँ अब कति हुन्छ यो 4 pi r square unit. That is the formula for total surface area of the solid sphere, which is equal to 4 pi r square unit. But it is not 6 pi r square unit. So the statement is false. So therefore, you can write here the statement is false. So here the statement is false. Is that clear? So you can copy it. Now we'll do the next question. So now we'll do next question, that is number 2. So let us write whether the following statements are true or false. So question number 2 is, the base radius of a solid circular cone is r unit, height is h unit, and the slant height is l unit. Now the base of the cone is joined along a base of a right circular cylinder. If the base radii and heights of the cylinder and the cone are same, then the total surface area of the connected solid is pi rl plus 2 pi rs plus 2 pi r square unit. त यहाँ क्वेशनमा के भनिँदैछ भन्दाखेरि, यहाँ क्वेशनमा दिएको छ एउटा solid circular cone is given whose base radius is r unit, height is h unit, and the slant height is l unit. Now the base of the cone is joined. The base of the cone is joined along with the base of a right circular cylinder. That is, the base of the cone is joined along with the base of the right circular cylinder. Okay. So now in the question it is also given that the base radii, that is the base radii and heights, the base radii and the heights of the cylinder and the cone are equal or same. Then the total surface area of the connected solid will be this much, that is pi rl plus 2 pi rs plus 2 pi r square unit. Whether this statement is true or false, you have to check it. So I think you have understood it. एउटा कोन दिएको छ हैन, त्यो कोनको बेस रेडियस कति दिएको छ, r unit दिएको छ, अनि त्यो base of the cone, it is joined with the base of the right circular cylinder. अनि यहाँ के पनि दिएको छ भन्दाखेरि, the base radii र height of the cone and the cylinder are equal. So the total surface area of this connected solid, यो जुन चाहिँ connected solid छ, त्यो connected solid को total surface area चाहिँ यति हो भनेर भन्दैछ. That is pi rl plus 2 pi rs plus 2 pi r square unit. So whether the statement is true or false, you have to check it. Okay. So there is a solid cone here. Suppose this is a solid cone. This is a solid cone. This is a solid cone, right? So now this is the height of the cone. This is the height of the cone. This is H, right? Suppose this is A, this is O, and this is B. What is the radius of the base of the cone? It is R. And what is the slant height? It is L. And now the base of the cone is the base of the cone. The base of this cone is joined with the base of the cylinder. That means the figure is like this. Now this is a cylinder, right? Suppose this is a cylinder. Suppose this is a cylinder. Now in the question it is given that the base radii and the height of the cylinder and the cone are equal. So यो जुन चाहिँ कोन र यो सिलिन्डर छ यो दुईटैकै हाइट र रेडियस चाहिँ के छ सेम छ भनेर भन्दैछ भन्छ रेडियस सेम भइगयो रेडियस इज r and what is its height this is also h. So what will be the total surface area of this connected solid? त यो कनेक्टेड सलिडमा हामीले यो फिगर चाहिँ एड गर्नु भएन बाहिरको मात्रै टोटल सर्फेस एरिया भनेको वरिपरिको एरिया मात्रै जोड्नु पर्छ ठीक छ त यो एरिया बीचको एरिया चाहिँ जोड्नु हुँदैन त्यो जोडे पनि रङ हुन्छ ठीक छ सो नाउ देयरफोर भोल्युम अफ द कनेक्टेड सलिड volume of the connected solid is equal to what is the surface area of the cone? What is the slant surface or curved surface area of the cone? It is pi rl. This is your pi rl plus अब यो एरिया चाहिँ जोड्नु हुँदैन है बुझेपछि त्यो त हामी देख्दैनौं त टोटल सर्फेस एरिया भनेको यो वरिपरिको एरिया मात्रै देख्छौं हामी त्यो भित्रको यो माथिल्लो यो एरिया हामी देख्दैनौं त अब सिलिन्डरको वरिपरिको एरिया के हो कर्व सर्फेस एरिया दैट इज 2 pi rh. What is the curved surface area of the cylinder? That is your 2 pi rh plus area of the base of the connected solid. What is the area of the base? That is a circle, that is pi r square. So this will be pi r square. This much square unit. This much square unit. Okay? So this is the correct answer. What is the, it's not volume, sorry. This is not volume. I wrote here volume, that is wrong. This will be the total surface area of the connected solid, okay? Therefore, total surface area, that is total surface area of the connected solid is equal to, that is curved surface area of the cone, that is your pi rl, plus curved surface area of the cylinder, that is your 2 pi rh, plus area of the base of this connected solid, which is equal to pi r square. So is the statement correct here? This is pi rl, 2 pi rh, यहाँ चाहिँ 2 pi r square दुईटा आयो यो पनि जोडेको छ त यो चाहिँ जोड्नु हुँदैन किनभने हामीले बाहिरबाट त यो एरिया त देख्दैनौं नि त टोटल सर्फेस एरिया भनेको चाहिँ बाहिरको एरिया मात्रै यो भित्रको एरिया हामीले एड गर्न हुँदैन. So this is the total surface area of the connected solid, that is pi rl plus 2 pi rh plus pi r square bracket closed square unit. त अघि मैले जुन चाहिँ यहाँ भोल्युम लेखेको थिएँ that is wrong. Okay, भोल्युम होइन यो चाहिँ हो total surface area of the connected solid. So I think you have understood it. So you can copy it. So here you can write here therefore the statement is false. Here you can write therefore the statement is false. यो क्वेशनमा जुन चाहिँ यो टोटल सर्फेस एरिया अफ द कनेक्टेड सलिड दिएको छ त्यो चाहिँ रङ हो. दैट मीन्स द स्टेटमेन्ट इज फल्स. सो आई थिंक यू हैव अंडरस्टूड इट. सो यू कैन कॉपी इट. नाउ विल डू द नेक्स्ट क्वेश्चन. So now we will do another type of question, that is 17 number C. Let us fill in the blanks. This is also from very short answer type question. So let us fill in the blanks now. So question number 1 is the base radii of a solid right circular cylinder and the two hemispheres are same. That is, the base radii of a solid right circular cylinder and the two hemispheres are same. Okay? If the two hemispheres are fixed with two surfaces of the cylinder, if the two hemispheres are fixed with two surfaces of the cylinder, then the total surface area of the new solid is equal to curved surface area of one hemisphere plus curved surface area of dash plus curved surface area of the other hemisphere. So you have to understand this question again. So there is a solid cylinder, and it is also given that the base radii of the solid right circular cylinder and the two hemispheres are same. यहाँ के दिएको छ भन्दा फेरि दुईटा हेमिस्फियर, दुईटा solid hemisphere र एउटा solid right circular cylinder are given. Okay, their base radii are same. That is, the base radii of the solid right circular cylinder and the two hemispheres are same or equal. Okay, now if the two hemispheres are fixed with the two surfaces of the cylinder, now in the question it is given that the two hemispheres are fixed with the two surfaces of the cylinder and a new solid is formed, and the total surface area of the new solid will be equal to curved surface area of one hemisphere plus curved surface area of dash plus curved surface area of the other hemisphere. Okay, so let us draw the figure in this case. So there are two hemispheres and one solid right circular cylinder. Their base radii are same, right? So this is a cylinder now. So this is a cylinder. So this is a cylinder. Suppose its radius is r. This radius is also r. Now the two hemispheres are fixed with the two surfaces of this cylinder. So one hemisphere is at the top of the cylinder. This is one hemisphere and this is another hemisphere. Okay, now these two hemispheres are fixed with the two surfaces of the solid circular cylinder. So the figure will be like this. Okay, what is the total surface area of this new figure or new solid? It will be curved surface area of the first hemisphere plus curved surface area of the second hemisphere plus curved surface area of this cylinder. So fill in the blanks ma ke huncha, cylinder huncha. Is that clear? The total surface area of this new solid bhaneko surface area of this first hemisphere plus surface area of the second hemisphere plus surface area of the cylinder. That means then the total surface area of the new solid will be equal to curved surface area of one hemisphere plus curved surface area of what? Cylinder. This will be cylinder. So here fill in the blanks ma ke bhayo? Curved surface area of the cylinder plus curved surface area of the other hemisphere. So this is the correct answer. That is, fill in the blanks ma ke huncha? Cylinder huncha. Is that understood? So you can copy it. So now we'll do the next question, that is 17C. Let us fill in the blanks. So this is question number 2. The shape of a pencil cutting one face is a combination of cone and dash. So you have seen the pencil, isn't it? The pencil is like this. The pencil is like this, isn't it? The pencil is like this, right? The shape of a pencil cutting one face is a combination of, so this is of cone, is a combination of cone. On the yo चाहिँ के portion भयो? This is the cylinder. This is a cylinder. Is that clear? the shape of a pencil is a combination of this cone and a cylinder. So fill in the blanks ma ke bhayo तिमीले के लेख्छौ cylinder भन्दिदिन. So this is cylinder. Is that clear? The shape of a pencil cutting one face is a combination of dash and cylinder. It might be given like that. This question might be given like this. The shape of a pencil cutting one face is a combination of dash and cylinder. So in that case, you have to write cone. Okay? But in this case, in this particular question, the shape of a pencil cutting one face is a combination of cone and dash. That will be your cylinder. So you have seen the pencil, isn't it? The pencil is a combination of a cone and a cylinder. Is that clear? So number 3. So question number 3 is, by melting a solid sphere or solid right circular cylinder is made. The volume of the sphere and the cylinder are dash. I already told you about this problem. That is, in this case, a solid sphere is melted. A solid sphere is melted and a solid right circular cylinder is made. त यहाँ के गर्यो, एउटा solid sphere लाई गलायो, मेल्ट गरियो, अनि त्यहीबाट के बनायो, solid right circular cylinder is made. That means the volume of these two must be equal. That is, the volume of the solid sphere and the volume of the solid right circular cylinder must be equal. Is that clear? So is made. So the volume, by melting a solid sphere or solid right circular cylinder is made. The volume of the sphere and the cylinder are what? Equal. Are equal. So I think you have understood it. So you can copy it. So now this much is for today. त आज हामीले जति पनि प्रब्लम्सहरु गर्यौ यो सबै घरमा रिभिजन गर्नु. You revise all the problems that we did so far in this particular chapter. So in the next online class, we will do more questions on this chapter, real life problems related to different solid objects. We will do from short answer type of question which carries 2 marks. So this much is for today.